Stopping Analyze Math Industry, and we are going to take a look at stoichiometry, part 4, and we're going to solve problems that have mass to mass. So, what's going to happen is we're going to solve the final formula to mass, which means this is the last video of the stoichiometry video series. So what we're going to do is we are going to solve the hardest formula to compute, and it's going to be on here. But don't worry, this will be simplified. So let's get to the problem. Sodium chloride and lithium oxide, which are these, react to produce sodium oxide and lithium chloride. If 10 grams of sodium chloride before it happened is used to react, what is the mass of LiCl? What is the mass of lithium chloride? So let's see what the instructions are and find what the formula has to say. So right here we have all the different formulas. We've already reviewed these two, but what we'll review today? Right, problem type number 3, mass to mass. So here's the plan. We have the calculated number of grams that is given to us. That will be 10 grams of sodium chloride. That happened before the reaction happened. After that, we then have to multiply by finding the molar mass thing. So what we have to do is find the molar mass of NaCl and try to convert it to moles, grams to moles. Then we have to do it by the ratio. So now we have to compare NaCl and lithium chloride. That is in the middle part. But the problem is, since this is a mass-to-mass problem, we will convert from molar mass to the ratio of the elements, but we have to get back to the mass of the other one. Now we have to find the mass of LiCl, lithium chloride, and that will give us the mass for lithium chloride as our answer, if the whole thing works. Looks like we are given 10 grams to start out with. Let's multiply that by, here is the main problem. We have to multiply by our very first molar mass thing. So what we have to do is find what the molar mass of NaCl is. If we do that, we'll proceed to compare the elements and the compounds. So with sodium, the molar mass is 22.99. And the molar mass for chlorine is 35.45. Referring to the other video last time, that is how much mass in grams it would feel like if we had 1 mole of these. So what we have to do now is add these 2 molar masses up because they don't have different subscripts instead of 2 or more. So what's going to happen is when we add them all up, we get 58.44. That is the molar mass for grams per mole. If we have 1 mole of NaCl, this is what the molar mass would be. And that would, if you had it in your hand, that's what it would feel like. So here's what's going to happen. Going back to the instruction sheet, we have to do mole on the top and grams on the bottom. So what we're going to do is put 1 mole of NaCl, and we have to divide that by 58.44. So that is our very first conversion for molar mass. Now we have to multiply by the easy part, comparing it with lithium chlorine, or lithium chloride. So since we already have 1 mole of NaCl on the top, in order to cancel that out, we have to do 1 mole of NaCl on the bottom. However, it's not 1 mole. What's going to happen is, going back to the balanced equation, if you take a look at NaCl right over here, you'll notice that there seems to be some kind of number 2 right there. So what's going to happen is we are going to say NaCl, but we're going to have 2 moles, not 1. So we're going to have 2 moles of NaCl. Then what's going to happen next is we have to compare it with lithium chloride. Lithium chloride. So over here, we're trying to find what is the mass of lithium chloride. So we have a 2 as a coefficient in front of it. So going back to the equation, we're going to say 2 moles of LiCl, lithium chloride. But there seems to be another problem in our hands. We went from NaCl, then we used the molar mass to convert to 2 moles of NaCl, but the problem is we now have to convert it back because we have mass to mass, but we have 1 mass, so now we have to bring it back. We now have to multiply by another set of these right here. But instead of NaCl, looking at the construction manual, now we have to do the molar mass of lithium chloride now. I promise, this is the last step of the entire problem. Now we have to multiply it by, but we need to find what it is. So, the molar mass for lithium is going to be 6.94. The molar mass for chlorine, well, just like the last one right here, is 35.45. We have to check if there's any subscripts besides 1. And turns out that lithium and chloride does not have any subscripts besides 1. Let's add them too. When you add them, we are going to get 42.39 grams per mole. So if I had lithium chloride in my hand, and if you had exactly 1 mole, 6.02 times 10 to the 24th power, then it would feel like and have a mass of 42.39 grams. So here's what's going to happen. Last time we had NaCl on the bottom. We're done. Now we have to convert from lithium chloride moles back to mass. So here's what's going to happen. From the instructions manual, again, we have to put grams on the top and moles on the bottom because they have to cancel out of each other. So we're going to say 42.39 grams per mole. That is going to be for 1 mole of LiCl. So here is the math part. When you calculate 10 times 1 times 2 times 42.39, divide that by 58.44, divide by 2 moles, and divide by 1 mole of LiCl, lithium chloride is going to have a mass of 7.25 grams. So we used from this mass of NaCl to the element of the mass we want just by going from converting from moles, 1 mole per gram, then we went to the ratios, then we did another one to turn back the ideas, then we brought it to 77.25 grams. That would mean in order for this balanced equation to be true and for the reaction to react, lithium chloride would have to have a mass of 7.25 grams. I hope this video has helped you understand stoichiometry part 4, mass to mass. Thank you for watching Tapping Your Life's Math Industry. Like and subscribe.